Good afternoon, my dear students. Let me continue wherever I have stopped in the previous class. In fact, I stopped at the how to test it for optimality by using modified distribution method, that is Moody method. But I think it is again better to explain it once again. Okay, that is what I envisaged, because whether the previous thing was really understood or not. So in lieu of that one, I want to continue the same problem with okay, these were the costs. Okay, after applying or using the Vogel's approximation method, we got the first initial feasible solution as the 1 unit is to be transported from P1 to D1, 5 units from P1 to D2, 1 unit from P2 to D4, 6 units from P3 to D1, and 3 units from P3 to D3, and 1 unit from P3 to D4, so that the rim conditions have been met. And these are the allocations we have found out by using the Vogel's approximation method. And if we find out the total cost, that is 1 into 2, 5 into 3, like that, because these 3 and other things, they are expressed in hundreds of rupees. So let us say those things. So it works out to be something around 102 into 10 to the power 2 rupees, the total transportation cost. If this one is compared with other methods, they give something around 111, few methods give 116, and few other methods they give something around 112 into 10 to the power 2 into 10 to the power 2, like that. So that means obviously the Vogel's approximation method, it gives the near optimal solution. Now our task is it the least transportation cost? How to know about it? For that purpose, the optimality test has to be done, and we are going to use the Moody method, or the modified distribution method. In the modified distribution method is a two-step process, wherein it considers the entire matrix and tries to find out whether the given the generated solution is optimal or not. If it is optimal, the current solution is the optimal solution. If it is not optimal, then it will tell which shell, which is presently empty shell, is to be brought in. Or if you look back to the simplex method, these empty shells are nothing but the non-basic shells, and the filled in shells are nothing but the basic variables. Okay, non-basic variables, non-empty shells are non-basic variables, and basic variables are the filled-in shells. Okay, if it is the optimum, it remains optimum. If it is not optimum, because after checking it for optimality, if it says it is not optimum, then one of the basic variable will leave, which will be the leaving variable. The another one will be the entering variable. That means which is currently the non-basic variable or currently non-filled shell, it is to be found out. That is what is done in case of modified distribution method. It tells that procedures as well. So first it tells us whether the solution is optimal. If it is optimal, we will leave it. If it is not optimal, it will give us the further direction. So as I told you, it is the two-step process. In the first step, we are going to find out what are called as the row and column coefficients, and they are also called as the Lagrange's coefficients. The row coefficients are denoted by Ui and the column coefficients are denoted by Vj's. These are called as the Lagrange's coefficients. These coefficients, they will, if we find out the values of these coefficients, they will tell us the implicit cost. So there are two things you need to understand. Whatever these things values, whatever I have written here, as I mentioned earlier, because the shell, whatever I am going to represent, it will be like this. This is the allocation, here the Cij values, and here Ui plus Vj values. This Ui plus Vj values are nothing but the implicit cost. Cij values are the actual cost. So we'll compare these things. That means implicit cost in the sense, if that particular shell is brought in, then the certain allocation will be made. Whether the transportation cost increases or decreases, that is what it tells. So Ui plus Vj values are the implicit values, and these things are the actual cost. Their difference, if I take, that will give us what is called as net evaluation. That means, another thing I can say, this is Ui plus Vj, I can say this is called as implicit cost. Cij value, it is called as actual cost. Cij minus Ui plus Vj is called as marginal cost or evaluation cost or marginal cost, evaluation cost or opportunity cost. These things are to be calculated for empty shells, because that it implies that if this value is Cij minus Ui plus Vj, or we can say this one together equal to Zij. Okay, so that means Cij minus Zij, it will have, it may be greater than equal to 0, or it might be less than 0. If for empty shells, these things are greater, Cij minus Zij values are greater than or equal to 0, then we conclude that optimal solution has been reached, because this value, it will increase, because it is going to be a positive value. If it is greater than 0, it is going to be a positive value. So that it is, ultimately it will increase the cost by that amount, whatever value it shows. corresponding to the present solution. If it is 0, the present solution itself, it remains holds good. And if it is less than 0, that means by bringing in by allocating something into that empty cell, it is going to reduce the cost by that much amount. That is what it says. Whatever the amount it gives here. Negative, of course, with negative, that means the transportation cost will be reduced by that much amount. Say, for example, if this value is equal to -1, that means every unit which is allocated to that particular cell, it is going to reduce the cost by 1 rupee. If it is -4, that means it will reduce it by each unit, the transportation cost will be reduced by 4. That is what it means. So that means compared to other things, it might be better. So it should be some of the values, whatever are currently are there in the cells, those things need to be allocated. That is what it means. That is how it works on that principle. And now Cij values already we know. Now to find out Zij values, which is nothing but Ui plus Vj values, and that means we have to find out Ui and Vj values. Ui are column variables or column coefficients, and Vj values are, Ui values are row coefficients or row variables, and Vj are column coefficients, or it is called as column variable, or both the things will be called as dual variables. That is what it means. So now we need to find out Ui and Vj values. How to find out? That is what is the crux of this one. To find out these values, that means I have to find out. I'll draw one more this thing, only one table wherein I am going to depict all the things. Instead of making several tables, this will become much more easier for us. Okay. The same thing I'll reproduce over here. P1, P2, P3, D1, D2, D3. In this place, I will call V1 is equal to how much? V2, V3, V4. This is U1, U2, U3. And these are the cost values. I have put Cij values. (15) and 9. And allocated values by WAM method: 1, 5, 1, 6, 3, 2. Of course, this will become 10, this will become 1, this will become 6, and total this addition 7, 5, 3, 2. Okay, for the time being, I'll leave it as it is. So the total cost of this one is going to be 102 into 10 to the power of 2 rupees. Now having done this one, now I need to find out Ui, I need to check it for optimality. To check it for optimality, I need to find out the value of Vi and Vj values. How to find out this Ui and Vj values? The first thing is, we need to assume one of the Ui or Vj values equal to 0. You might ask me the question, why? Because I can frame only 6 equations using the filled in cells, because you can see that here the filled in cells are at the most they are going to be 6. That is why you can recall now, if it is a non-degenerate basic feasible solution, it should have exactly m plus n minus 1 allocations. For this reason, otherwise it cannot be tested for optimality. So fortunately we have got it satisfied that first condition, and it satisfies the marginal conditions as well, that we know already. Okay, that is the rim conditions, it satisfies equal to this one, that is all other things are known. Now, if you observe, there are 6, because filled in solutions, we are going to find out the values of ui and vj's. The governing equation for that one, if you want me to write, how we will do is, ui plus vj is equal to cij for the filled shells. So there are 6 filled-in shells. Ui plus Vj is equal to Cij. For example, for this cell, U1 plus V1 is equal to 2. For this one, similarly for this one, U1 plus V2 is equal to 3. Similarly for this one, it is U3 plus V4 is equal to 9. That is how we are going to find out. So if we go on finding out like this, I am going to get 6 equations. But how many variables I have? 4 plus 3, 7 variables, it is not possible. Then what is to be done? Since this Moody method, it depends on the relative cost method, we can assume one thing is, one of the variables value is equal to 0. Since it is based on relative cost, that means I will prefix the value of any one of these variables out of 7. I can make u1 is equal to 0, u2, u3, v1, v2, any one value is equal to 0. That means I am left with 6 variables and the 6 equations, so I can find out the other values. But here the easiest thing would be, because in that it would be to assume that particular value of Vi and Vj where there are maximum number of allocations, so that it becomes much easier for us to find out the other values. For example, here I will assume U3 is equal to 0 because it has got maximum allocations. Any other row or the column will have lesser than that. If they are equal in some column or this thing, arbitrarily you can choose. There is no hard and fast rule for this particular thing. So I am assuming U3 is equal to 0 for this particular reason. So what is the value of V1? Now because U3 plus V1 should be equal to 5. Now I have prefixed the value of U3 is equal to 0. Hence, what should be the value of V1? V1 should be equal to 5 only. There is no way out. So how much simple it becomes easier now. Okay. Now this one I don't know right now. This one I will find out. V3 is equal to 15 because this is 0. This is equal to 9. Because one of the values are to be known. That is what we need to find out. Then how to find out this one? What is the way to find out this? Okay. That is what we need to find out. What is the value of V2? How to find out this? Now we know U1 plus this thing is going to be U1 plus V2 has to be 3. But what is the value of U1? How to find out? Already I have found out V1 is equal to 5. Then I know that U1 plus V1 is equal to 5. That means, but U1 plus V1 should be is equal to 2. That means what should be the value of U1? U1 has to be ultimately 5 minus the 2 minus 5, that has to be minus 3, because 5 minus 3 it is going to be 2. Having found out this one, I can, now it becomes easier for me to find out the value of V2. What should be the value of V2? It has to, because this one minus 3 plus V2 should be equal to 3. In that case, V2 has to be naturally 6. So 6 minus 3 is equal to 3. So all these values have been found out except U2. Can I find out the value of U2? Because we know that V4 is equal to 9, and then V2, U2 has to be how much? It has to be minus 8. Because minus 8 plus 9 is going to be 1. So all the values have been found out. These are, though all Lagrange coefficients or dual variables values have been found out. Don't be under the impression that always these are going to be the values. No, the answer is no, because since you have made U3 is equal to 0, these values will become like this. If you make U1 is equal to 0, these values will be changed. But our decision is not going to be changed, irrespective of that. That is to be understood. So never compare your answer. Don't compare your answers. Hey, how much U3 you have got, U1 you have got, V1. No, it depends on which of them you have made 0. If you make this one as 0, exactly you will get like this. But if you make U1 is equal to 0, then you will be getting different values. So don't go by that. What we have to aim it as at the end result, ultimately it has going to be same. And whatever the direction it gives, irrespective of that one, only this, whether it is optimal or not, this will also tell. And when you make U1 is equal to 0 and then find out, again it will say that if this one says that it is non-optimal solution, that will also show that it is non-optimal. Try to understand that. Now I will find out what are the values of these things. Ultimately, if you look at this one, is there any point in getting the difference in marginal cost for this one? There is no point, because we know that this one plus this one is exactly equal to 2. So if I take the difference of this one, it is going to be 0. 0. There is no point. So for all these things, they filled in cells. Even if you calculate or you don't calculate, it doesn't make any difference, because ultimately that value is going to be 0. So we need to, because only it can be used as a cross check. For example, here 5 minus 3, 2, 2 minus 2, 0. Here 6 minus 3, 3, 3 minus 3, 0. So these things are correct. That is what we can find out. We can, for non-empty cells, we need to find out. So 15 minus 3, this is going to be 12. 9 minus 3, this is going to be 6. 15 minus 6 minus 8 minus 2. Okay. 15 minus 8, this is going to be 7. This is going to be 6. No point in finding out for this. 5 minus 8, it is going to be minus 3. Okay. So we have found out the UI plus Vj values like this in the same table. So now I will find out the difference between these two. 11 minus 12, this is going to be minus 1. 7 minus 6, it is plus 1. 6 minus 7, it is minus 1. 0 minus of minus 2, it is going to be 2. 1 minus of minus 3, it is going to be how much? 4. 8 minus 6, it is going to be 2. So try to concentrate on these values. These are the marginal costs. That is how we have got the marginal costs. If these marginal, all these costs were greater than or equal to 0, then the optimal condition would have been reached and the present solution, this is the present solution, that is whose value is 102 into 10 to the power of 2, total transportation cost would have been the optimal. But here, now we see that 2 of the empty cells have got minus 1 value. That means optimal condition is not reached. There is a possibility that for allocation of each unit, either in this cell or in this cell, for each unit, that means for each of 1 million liters of milk, one is going to save 100 rupees. That is what it means. So maximum possible you can allocate here, whatever the maximum possible. Okay, but this not disturbing the rim conditions. Okay, that is what is to be understood. Now, usually what we should do is this, whatever the negative value we get, that the net evaluation or the marginal cost, whichever is the most negative, that cell needs to be allocated. That means in the present solution, it is the non-basic variable. It has to be made as basic variable compared to simplex method. That is how we can talk about it. Or this is either this one or this one is the entering variable corresponding to this one, because one at a time, only one cell is to be filled in, the another cell will become empty. I will make it empty. So that will, which will make it as empty cell, it is called as the leaving variable, which we are going to introduce here, that now presently it is empty, which will become occupied, allocated some values, it is called as the entering variable. Okay, and which one, that is what here both are same. That means arbitrarily I can select any one of them. If it were -2, then definitely I would have selected this one. If it were -2 and this is -1, but here both are same. Anything you can select. But let me select this one. So having selected, I'll mark it as right. That means this will become the entering variable. Some allocation has to be done. Whether I am going to put 1 unit or 2 unit, 2 million liters or 1 million, 3 millions, like that. That is to be found out now. Now, the moment I have made this one is to be allocated, instead of 6, now they will become 7. Okay, that this thing is disturbed now, balancing. It is disturbed. So, ultimately, if it is to be corrected, anything, whatever, if we want to do, 3 cells will be naturally, because if I want to bring in allocate some value to the empty cells, then at least some 3 cells will be affected. What are those 3 cells? Let me find out. Now, having done this one, what we'll do is, we'll try to draw the closed path. That is the principle of this one. Closed path is 1. If the number of allocations are more than m plus n minus 1, then it is possible to draw the closed path. If it is less than that, it is not possible. Okay. That means here, and the closed path in the sense what? The corner points, whatever are there, cells, those are important. Because we can move only in horizontal way or vertical way. And those corner points I can make a vertical, or I can change my direction, make it horizontal or vertical. And for other cells, whether it is empty or non-empty cells, we can just pass through. Okay, that means having identified this one, now what I will do, I will pass through, this is an empty cell, I can pass through, I can come over here, because this is the corner cell now. From here I can take this direction or this direction. Suppose if I take this direction, I can go here. From here I can go here. Then I cannot go anywhere. Instead of that one, what I will do, I will take a left turn, I will go here. I will pass through this one, I will come over here. From here, I can take the turn, and I will come over here. And from here, I can pass through this one and reach again the starting point. Is it understood? That means it is possible to draw a closed circuit if more than m plus n minus 1 allocation we have considered. That is what it needs to be allocated. How much is to be allocated, that we need to find out. Because this has to be allocated. That is what we say. Having said that one, now what I will say, it should get allocation. That I will say it will get some allocation plus. Now alternatively, you make this one, you have made plus, then you make it negative, you make it positive, you make it negative, and when it passes through this one, you leave it as it is. So you can go either in a clockwise direction or anti-clockwise direction, no harm. But starting with this one as plus. Even if I had gone plus, minus, plus, minus, plus. If I go like this, it is also like that. What does it mean? Wherever it gets the value of minus, that present allocation is to be deducted. That is what, that much amount. If it is plus, that much amount, what much amount is to be added, let us see. Now you try to concentrate the values which have been marked as negative. Now in this one, in this closed path, there are two corner values which have been marked as negative. This is one is 3, another one is 1. They are not negative allocations. Don't be under that impression. They have been marked negative. That's all. Okay. Out of these things, which one is least you have to consider without considering that negative sign. 1 is less or 3 is less. Obviously 1 is less. So that means whichever is least, that we need to consider. And if both are least, then you have to consider that one only, both the things, and that will lead to degeneracy during generation of the next solution. That is what we will talk about, maybe in some other session. That is, try to understand. So if simultaneously they will become 0 because number of allocations will become lesser than m plus n minus 1. In this case, okay, this will be shifted, so it will come somewhere. Say for example, here I will tell you, the allocation, this was the allocated cell, this will be shifted, 1 will be shifted and it will be put over here. So this will become the leaving variable. Again, in lieu of this one, this has become, and again the number of allocations would remain same, that is 6 only. Let us see how it works. So you have understood this one. This is 3 and this is 1, which have been marked with the negative value. Out of this one, 1 is least. So I am going to add that one to the correspondingly marked values. So here it will get 1. This is instead of 3, what it will become? It is 3 minus 1, this much. How much this will become? 2. Here instead of 6, it will become 7 because 1 is to be added, so it will become 7. And here 1 minus 1, it will become 0. That means it will leave. And since it is just passing through, I will leave it as it is. Now you can just see how many allocations are there. 1, 2, 3, 4, 5, 6. And if you look at the rim condition, 5 plus 1, 6. 1, 1, 7. This 7 plus 2, 7 plus 2 plus 2. This one, what has happened? 1. This is plus 1, 7. This one, this is not 2. This is, sorry, this one should have been first. This one, because I have not considered that one. 7 plus 2 plus 1, 10. 1, 5, 1 plus 1, 6. This one is 7. This one is 5. This one is 1 plus 2, 3. This is 1 plus 1, 2. So perfectly it matches with this one. What is the cost? So according to me, because 1 unit I have done this one. So earlier this had given 102 into 10 to the power 2, so many rupees. Now I say that it will not be 102 into 10 to the power of 2, but it is going to be 101 into 10 to the power of 2, because if you multiply this one by this one, that much is to be deducted. And really, if you work out like that, if you find out, it is working out to be 100, and that means 101. Or if you want me to show the calculations, I can show you. 3 into 5 plus 1 into 11. This is 1 into 1. This is 7 into 5 plus 15 into 2 plus 9 into 1. 35, that is 65, 65 plus 9, 44, 24. 35, 30, 65 plus 9, 74. 1. This one is 15 plus 16. So this is going to be, this works out to be 101. This is what we are going to get, 101 into 10 to the power 2. Now next again we have to question ourselves, is it the optimal cost? What is to be done next? Again the same thing procedure is to be repeated. What we will do next, because second feasible solution, this is like this. Now is it optimal? That we have to find out. If it is not optimal, then what is to be done? We have to see. So again, the same thing is to be repeated. Two, 3, 11, 7, 1, 0, 6, 1, 5, 8, 15, 9, and the allocations are 5, 1, 1, 1, 2, and 7. Okay, which is because this is the second solution we have generated, and it's this thing is how much? The total cost is going to be 101 into 10 to the power of 2 rupees. So we are checking it for optimality. Again, we need to find out what are the Lagrange's values V1, V2, V3, V4, U1, U2, U3. Again, the same procedure needs to be repeated. The same value will not get. Try to understand. Again, which one will consider it to be 0? Wherever the maximum allocations are there, again it happens to be U3. I will consider U3 is equal to 0. And now, once I consider U3 is equal to 0, what is going to be the value of V1? It is going to be 5. What is going to be the value of V3? It is going to be 6. This one is 9. Okay. And this is going to be how much? Because we have found out this one, this is going to be how much? 9. Okay. Try to understand this one. Earlier, V3 was how much? V3 was 15. That is why it will not remain, because we will go by this one. Because this is the allocated cell, already I have found out the, sorry, here I need to, V3, U3 is 0, V3 is going to be 15, sorry. Okay. This is 5, this is V3 is 15, and this is 11. So this value, U1 value is going to be minus 4. Try to understand. Earlier it was minus 3, but now it is going to be minus 4, because we are getting the allocations here. Earlier this allocation was not there. That is why. So this is the 15 I got, and this one to 15 minus 4, this is going to be 11. Okay, I have found out this thing. So this value is found out. Now, can I find out, having found out the value of U1, I can find out the value of, because this one, when I add up these two, I should get 3. That means naturally this one has to be 7. 7 minus 4 has to be 3. And U2 value I can find out, because V4 is equal to 9, and then U2 plus V4 should be equal to 1. That means it is going to be minus 8. Okay. minus 8. Okay, fine. Okay. Now what is next we need to find out? Because if you find out this one, 0, 0, there is no point in this thing. So I'll find out this one, 5 minus 4, how much it is? 1. 9 minus 4, 5. 15 minus 8, 7. 7 minus 8, minus 1. 5 minus 8, minus 3. 7 minus, 7 plus 0, this is 7. Okay, other things I need not have to find out. So now 2 minus 1, this is plus 1. This of course it will become 0, this is no point. 7 minus 5, this will become 2. 6 minus 7, it will become minus 1. 8 minus 7, 8 minus 7, this will become 1. 1 minus 3 of 1 minus of minus 3, this will become 4. 0 minus of minus 1, this will become plus 1. Okay, now you observe one more shell, it is existing because when I find out the marginal cost, all the shells they have got except this, they are greater than or equal to 0, but it is existing at less than 0. Hence, the optimal condition is not reached. That means these present allocations, whatever we have done, these allocations, these are not optimal. Again, still it can be improved further. Unfortunately here, what has happened, there is only one shell which has got marked as negative. So next time what is to be done? This should get certain allocation. How much allocation one should get? It can be got only through by tracing the closed path. That we say that this should get. Okay, because this is the identified shell. So it is going to get some allocations. Now with respect to this one, is it possible to form the closed loop? You just try to see this one. Okay, from here, I'll come here, I'll come here, I cannot go elsewhere. I can go here, I can go here, I cannot go elsewhere. I can come here, yes, I can form the closed path because always it is possible. If there are m plus n minus 1, more than m plus n minus 1 allocation, then always it is possible to form the closed loop. That is what it does. Because just try to understand this, drawing this closed path, the closed path, that itself is one creative work involved here. Or by intuition or other things you will get. So here I'll go like this, like this, like this. Yes. That means this is plus, this is minus, this is plus, this is minus. And again this is plus. Now again you observe whatever is marked as minus, this is minus, value is 1, this is minus, the value is 2, which is least, the least is 1. That means corresponding values will be added to the things. So what happens ultimately, this will get 1, so it will become, earlier nothing was there, 0, now it will become 1. Now 1 is to be deducted, so it will become 0. Earlier it was 1, now 1 is to be added because it has left, so this will become 2. And this one is to be deducted from here, this will become 1. That is how these changes will be affected. That is what I told you. At least 3 cells will be involved. There these things are changed. Okay. Now what happened? So this has become leaving variable, this has become entering variable. First we have identified the entering variable. entering variable is 1, wherein the most negative value of the marginal cost will become that cell which has got the most negative value of the marginal cost will become the entering cell. That is what has happened. Now, if you look at these things, 1, 2, 3, 4, 5, 6. There are 6 allocations. They are all in independent position. You cannot form any closed loop. You can just see. It is impossible to form the closed loop. So, what is going to be the cost for this? Now, let us find out the cost. That is 5 into 3 plus, or I will put it like this. Or before that one, let us see 5 plus 1, 6. 6 is the requirement. This is 1. 1 is the requirement. 7 plus 1 plus 2, 10 is the requirement. 7. This one is 5. This one is 1 plus 1 plus 1, 3. This is 2. That means rim conditions are satisfied. So, this is the feasible solution. Not only it is basic feasible solution, it is non-degenerate basic feasible solution. So, the cost we will find out. The cost is 3 into 5, 11 into 1, 6 into 1, 5 into 7, 15 into 1, and 9 into 2. If you add up all together, they are going to become 100 into 10 to the power 2 so much rupees. Total transportation cost. Okay. Now, this is the thing we have got. Next question is it optimal? Because compared, we started with what? You started with 102 by VAM method. Then we came down to 101. Now we have come down to 100. But if we had started with some northwest corner rule, then I had to start from 116 and then go on reducing like that, the number of iterations will have been more. Here it has been reduced. Is it the optimal? That is what we need to check. Again, the checking procedure is same. So I will try to consider the same table because I have got that flexibility because of this blackboard. Okay. Only these things I need to rub it off. Again, I need to find out the new values of U1, U2, U3, V1, V2, V3 and V4. Again, the same procedure is to be adopted. Okay. Now, we'll try. Two allocations, one allocation, three allocation, 1, 1, 3, 1. So, either I can make U3 is equal to 0 or V3 is equal to 0. Any one of them we can consider it. Okay, for this time, for a change, let us consider V3 is equal to 0. Okay, fine. V3 is equal to 0. Then if it is V3 is equal to 0, what is going to be the value of U1? U1 is immediately it will become 11 and U2 will immediately it will become 6. It will become 15. We just try to see. By assuming these values, maximum values, whatever are there, how much easier it is to calculate those things. Okay. Now, what about this one? 11. That means what? It should become 11 plus V2 should become 3. That means the V2 has to be 11 minus 8 will become 3. That means we have found out the value of this. Okay. Now, these values we have found out, V3 values we have found out, 11, this one. Now I need to find out this 15 I have found out. So this is 5. That means ultimately this has to be 10. Okay. Sorry, this is not just 10, it has to be minus 10 because you need to be careful. 15 minus 10 is equal to, it should be 5, not 10, it is minus 5, minus 10. It is not just 8, it is minus 8. Again, if you go over here, that means this is 15, and I should get the value of 9. That means 15 minus 6 will become 9. Otherwise, it is not possible. Okay, got this one? This is not plus 6, it is minus, because if you add up this 15 minus 6, I should get 9. Okay, these things are correct now. If you want to verify, you can verify over here. Okay. Now what is to be done? You have to find out ui plus vj values. That means here how much value it is? 11 minus 10, it is 1. 11 minus 6, 5. 6 minus 10, minus 4. 6 minus 8, minus 2. 6 minus 6. 6 minus 6, it is going to be 0. And I have to find out this value. 15 minus 8, this is 7. Now, 2 minus 1, 1. 7 minus 5, 2. 1 minus 0, 1. 0 minus of minus 2 plus 2. This is 8 minus 7 plus 1. Okay. Can you observe this one here? So, sorry, this 1 minus of minus 4 plus 5. So, all the values are positive, because whatever the net evaluations are positive, hence the optimum solution is reached. And this is not only the optimum solution, it is the unique optimum solution. Try to understand that one. So the total transportation cost is going to be 100 into 10 to the power of 2 rupees to transport so much millions from P1. How much? From P1 to distribution center to 5 million liters, from plant 1 to third distribution 1 million liters, from plant number 2 to distribution center 3 1 million liter, and from plant number 3 to first distribution center 7 millions, third distribution center 1 million, and fourth distribution center 2. So totally the requirements are met. Hence this will give you the optimal solution. Is there any doubt or any question on that? So let us think about that one. Okay. If there are no questions, I am going to stop at this point. But before that one, let me recapitulate what are the things we have done. How we started with this particular transportation problem, transportation type of problem, or the topic is finding the solution by using the transportation technique. So first thing is, what we have done, which method is to be applied. To understand that one, we need to analyze the given problem. If the given problem consists of, what are the things we will think about that one? It will have certain nature. That is the characteristic. One of the characteristics is whether from to, here, there, present to past, or present to future. It is these things are there or not, we have to see. Or destinations and origin, like that. These things are given. If these are the things, then it is a likely candidate to be solved by transportation technique at the outset. But again, further analysis, again we need to think. If they have got the same units, that means requirement or the demand, availability or the supply, whether they are expressed in the same units, then it will become more suitable to be solved by the transportation technique. Okay. Next, we need to think, these are the things which can be applied, and afterwards it needs to be put in the form of the standard form which can be solved by transportation technique. So these are the two things you need to look into. One is from and to type of characteristic. Here to there, or that is what I told you. Again, I don't want to repeat it. And supply and demand, and if they have got the same units, they are expressed in the same units, then it can be handled by transportation technique. And if it is to be solved, then how it is to be solved? Let me put it in the form of the flow chart. Because first you need to identify that it is